exact area. So this first piece right here is an integral sign. So I'll call it S for sum. But this is an integral sign. It's an elongated S, which we'll talk about later. But it's like a curvy little guy, okay? On the bounds of it, so at like, it has bounds, so you're gonna have to put like, sometimes it doesn't, sometimes it does if we're finding an exact area on an interval. The interval goes on the ends of it. So like the smallest number goes on the bottom and the biggest number goes on the top. So if we're going to integrate, so again, this, here we will put this in highlighter. This sum represents this guy, like the area under this, okay? And if you're integrating from, you're finding the area from 0 to 4. So on that interval on the graph, I'm going from 0 to 4. And then the equation of what you're finding the area underneath goes there, x squared, because they told me that was the equation. And then dx is, again, we're going to talk about that a lot more on where this notation comes from. But when you see stuff that looks like this an integral thing, that means exact. So a lot of the times they're going to say like approximate this with a Riemann sum. So this means exact. What we're going to do now is approximate, okay? So we're going to do the area under the curve on interval 0 to 4. And we're going to do left endpoints, and we'll do 4 rectangles. I should add that in. Using 4 rectangles. Okay, so there's left endpoints, right endpoints, and midpoints. So there's 3 different types of rectangles you can do. If we're going to do 4 equal rectangles, what that basically means is we're going to do like, this is going to be the width of one of them, width of a second one, third one, fourth one, right? So all the rectangles are like, you know, length of 1 or width of 1, okay? Now if we're using left endpoints, okay, the height of each rectangle is determined by the curve, okay? So like, you either are going to use right endpoints, like you're going to focus more on the right side of the rectangle, the left side of the rectangle, or the middle. So this first rectangle is kind of goofy. We're using left endpoints because the height of this guy would be, it'd be the width 1, but then the height is like on the left side from the equation, which isn't anything. The height is 0. So just bear with me. I know the first one is kind of goofy. Okay. So my first rectangle doesn't really have a height. So you're like, this is fun. This makes sense, you know. But the second one, okay, has a width of 1, right? And this would be my rectangle here. Like this is my width, right? And my height is determined by the left side. So on the left side of the rectangle, I'm going to go up to where the curve is at 1, okay? So this would be like what my little rectangle guy looks like, okay? So the height of that rectangle, if you like don't know how to find it, you just throw it into the equation, right? So if you're plugging, this is kind of like doing like f of 1. Right? So if I plug in f of 1, I get, it's essentially like I'm taking 1 squared, right? I'm just like plugging it into the equation. Then if I go on my next rectangle, because that's how the height is, because it's on the point.
So you just counted how many?
Yep, it goes up 1, or if I plug 1 into the equation, I get 1. Yeah. So then the second one, it's harder when it's like so small. So like the second one is determined by the left would be, look like this, right? So the width of that rectangle is still 1. That's why I put the 1 there. And then to get the height, I'd plug it into the equation. So I'm using the left endpoint, you know, like at 2. So I'm going to go 2 squared. So 4. I mean, you can look at the graph. But if I need to get like exact, that's how I would do it. And then the finale, the 4th rectangle, still has a width of 1, but it's going to be over here. Okay. Now, if you look at that, if I were to do the exact area under the curve, so if I were to actually like shade in under the curvy thing, this is like a way underestimate, right? For the actual area. Like, look at all this hole. Like, there's all these holes in there. Like, there's this empty space. So this one in particular is in underestimate, right? Underestimate for that one. Okay.
Why did you leave it at +1?
Oh, because it died 3 squared. Okay. And then add them all up, 14. Yeah.
How do you know it's like it's 3 squared, not 9 squared? Yeah, I was.
Because this is like the x. This is the x.
Yeah. Oh, so
And you have to get the y.
I get that part, but how do you come up with the number? By plugging in the x.
And then right endpoints, it's basically the same thing for width. Like you're doing the same width for all of them. Right? So the area for this is going to be 1, but now I'm using the right side. Okay, so my height is determined by the right side of the rectangle. Right? So the width is 1, and then the height is plugging 1 into the equation. And then the next one is similar. Width is 1, but then the height would be 2 squared. I'm using the right side of the rectangle because I'm doing a right endpoint. Okay. Plus 1. And now I'm using 3 squared. And then grand finale is the 4th rectangle, which means now I'm going to have to be plugging 4 into the equation, right? Because I'm using it, the height I'm using is on the right side. Okay, now you can tell for that estimate, it's kind of the opposite, right? It's way too much. It's way over the actual curve. Because think about, like, this is the actual, right? Like it would be the, if I were to shade all this in, right, this would be the actual. So the left endpoints gave me an under. This guy is going to give me an over. Okay, so these are both over. Oops, I didn't figure out the answer. This is 30. Okay. Now midpoints, this one's the most annoying in my opinion, but it still is fine. Is you're now using the middle of the rectangle to get the height. So like your widths are still the same because we're still doing like 4 rectangles. The widths are all 1, like that's still the same that we've been doing here. But now the height is just more annoying to find because they're not always nice numbers, is I have to use the middle to get the height for like how much I go up. So like for this area, wait, do I have any room here? I'm going to have to do, I've got width is 1, that doesn't change, like this is going to be 1. So it's going to be 1, but then my height is determined from like the middle of this thing. So I mean, it's a real dinky rectangle, but it works, whatever, I guess. So how do I get that height, right? Well, it's the same as I do the other ones. You know how I did like 1 squared? I'm going to do the same thing, but I'm just going to put, if I'm doing the middle, isn't this like a half? I'd plug in. A half and squared, right? Actually, I should adjust those parentheses. Here we go. And then the next one is still width of 1. But then my height, again, I'm kind of like trying to eyeball it the most I can, right? When I draw it, would be like there. You know? It's weird because I don't like drawing the height in the middle. But it's just like, my opinion doesn't matter, you know? So we're just going to kind of go with it. But that would be the height of that guy. Okay. And, okay, wait. Now I got to think more. Because this is 1. You know, like on the graph. Because I have to figure out how high that is. I can kind of maybe cheat by looking at the graph. But here, that would be like 1.5, right? Because this is going up. This is 1, 2, 3, 4, you know. So it'd be like 1.5 squared. Or 3/2 squared. I don't know, whatever you feel like writing. 1.5 squared. That would give me the height of it. And then you keep going. So plus, and then the width's a 1 again. And then I hate doing the middle thing. Because I'm a little crazy about how good it looks. And okay, so then that would be what would that be, 2.5, right? Square it because I have to plug it in, and then I'm running out of room, so that's going to bother me. It's going to be fine. And then 1, and then do the middle of the last guy, which would what be 3.5? 3.5 squared. And I'm so good at mental math. This equals 21. Okay. Okay, so this one is the hardest to tell if it's over or under. This one we'll talk about later on as we go. Probably the smallest rectangle is the easiest to tell, whether it's an over or an under. If you look at the tiniest guy, okay, so that little dinker on the end, okay. If you look at that one, look at this area compared to that one. That's how I look at it. Okay, so like, look, because like obviously part of the rectangle's over it and part of it's under, you know, of like the actual. But do you see how there's less above the curve on the left and more white space under the curve on the other side of it? This is an underestimate.
Wait,
okay.
what did you say about the left side?
Like this has, this is over the curve, this is under the curve. And if you compare them, there's more blank space under the curve. Okay. Yeah.
How did you get like 1/2? How did you get 1/2 and 1/5?
Oh, I just looked at like the X values. So I use like, cause here is like 3.5, you know? And to get the height, I plug it into the X to get it. Yep. Okay. All right, so when you're doing more rectangles, yeah.
I was gonna ask, like, does like the left endpoint underestimate change for like
Different types?
different type of things?
What a good question. That's this, okay? So for these, like you can memorize that, good for you, I'm not. It's hard to tell when you do a lot of rectangle, especially midpoint. I'm like, I don't like midpoint that much. To figure out like what's an over, what's an under. Okay, so if I have on a multiple choice or F or Q, I'll like draw a quick sketch and then I'll figure it out. So like for example, we have every combination, increasing concave up, decreasing concave up, you know. decreasing concave down, increasing concave down. So we try like to get all the scenarios, right? So what I do if I'm like not positive, besides memorizing, because I hate memorizing, draw a giant rectangle the width of the interval, okay? And use your left endpoint. It's very clear to me that's under. Do you know what I'm saying? If you draw one giant rectangle where this is your width and this is your height. Do you know what I'm saying? So that's going to be under. If I do the same thing here, giant rectangle, use my left side to get my height, that is clearly an over for me, right? Same with decreasing concave down. Here's my width, here's my height, right? We're only doing lefts, that's going to be an over. Width, left, that one's clearly under. Right, so if I'm using just straight up left, because this is my height, where I'm getting my heights from, right? And the pattern is, as far overestimate is first, and when I want you to look at that, is they're both decreasing. That's what's in common with them, right? They're always, for a left Riemann sum on a decreasing function, it is always 100% of the time an overestimate. So you can memorize that, good for you, but there's too much in your brain already. Like all those derivatives you had to memorize with the trig. Like, why don't you just draw a pick? It's so much faster, right? Same with the right, okay? There's going to be something in common with all the right. So this would be over. Increasing is underestimate. Sorry, I didn't write that in there. So that's what's in common with them. Now if I did right, again, draw your width, being the width of the whole interval, so it's easy to tell. Why? Well, why is that happening? Guys, I don't want to do the doc cam. Do I have to close it? Maybe. Okay, let me try this again. It's going. Okay. Sorry, that was taking my time. Okay, you guys can start drawing your right ones. Just draw the right side. Okay, there we go. Does that work? Maybe? Okay, so your right ones, what is that from? Here we go. Here we go. So this would be your height. It's on the right side. Oh, look, way above. Here's your height, right side. Way below, right. Way below, right. Way above. You know what I'm saying? And then figure out, like, what's the commonality, right? So what's the overestimate? What are they always doing? Increasing. Oh my gosh, it's opposite of left. That's shocking. Oh my gosh. And decreasing always concave down. Okay, memorize, sure, but waste of life if you memorize. Okay. Now this guy, I think midpoint's the hardest, but draw a giant rectangle. Okay. So there's all my widths, and my heights are in the middle, which I hate drawing these. And this one you have to compare like the blank space and the like filled in space. You know what I'm saying? Because like this one, the blank space is less than the filled in, right? So this is an underestimate right here on this one, right? This would be an under. This guy, what is that one? That's kind of the same thing. There's more black or gray or whatever you want to call this. There's more gray than blank space above it, right? So this is also going to be an under. So what I'm doing is, like I'm saying, I'm comparing this compared to this. That's what I'm doing, right? Okay. So that orange piece on the left is more. And then here, same idea. This one, it looks like the airspace is bigger. Not by much, but this is going to be an over. This one, and this over. So what do they have in common? The overs are concavity, concave down. Okay, and this is concave up. Again, throw it in your brain or draw a pic. Okay. All right. So, sigma notation. You're introduced to it in pre-calc. Okay. Sigma is just like fancy math lingo. Okay. So, what you're doing is this piece. What did I do for? I'll put that in black. This part is the adding. Okay, so like this, the sigma is you're adding up all the rectangles. Okay, this guy right here, this f of x, that's like the y, right? Like up and down. Well, the up and down in rectangle world, this is your height. Okay, and then your change in x, for now anyway, is on the horizontal. Okay, your change in x, each of these guys, that's your width. Okay, so we're going to kind of be going through all of that throughout the class or throughout the unit of being like we're dealing with rectangles constantly. We've got a height and a width, height and a width. Your change in x, the width of each of your rectangles, if they're equal, is this little equation here. Where all it is this is like your interval, right? So if you're going 0 to 4, you go 4 minus 0, so 4. Or if you're going 1 to 12, right? Your interval is 11, right? You find your interval, and then you divide by the number of rectangles you want to do. Number of rectangles, and that'll give you each little width if they're all equal, right? So here's all your widths, your change in x's, and then you get all your heights, either left, right, wherever. This one's a left, okay? This is all your heights, your f of x, right, to get all your answers. So we're going to get into that even more as we go. Okay, so as far as to like kind of put it in, estimate the area between the graph of f of x and the x-axis from 0 to 1 using 4 approximating rectangles and right endpoints. Sketch the graph and its rectangles. If you want to draw it, that's fine. I mean, sine of pi x. I don't think I want to deal with how that's going to look, but if I were to graph this, it's just this guy, altitude's 1, and then I would hit a 0 at 1. Okay, so we're going from 0 to 1. This is our interval, right? We're going 0 to 1, and we're doing 4 rectangles again. And we need to figure out, we're doing right endpoints for rectangles, okay? So what you want to do is, what I usually do is first figure out my width. You know, like what's the width of each of these? Now I'm only going 0 to 1. 0 to 4 was nice because it was like 1, you know? But to find the change in x, I mean, a lot of you can maybe just look at it, figure it out. The formula is you find what's the width of the interval. So 0 to 1, I wonder how long that is. You guys could probably do that in your head, but technically you just subtract them. And we want to do 4 rectangles. So the width of each rectangle is a quarter, a fourth. I mean, you guys, you go 0 to 1, you got to break it up into 4 pieces. You probably could figure that out. You know what I'm saying? So like each little width is going to be a fourth. Right? If you cut it up from 0 to 4. not each tick is 1/4 because you know how to like count, right? So like it would be a quarter, then a half, then 3/4, and then 1, right? To go as a width of a quarter. So these are each of my widths, right? And then, so a lot of times if we're doing right endpoints, this notation's a little outdated, but they do R sub 4 to say right Riemann 4 rectangles. And you're going to do just like we were doing before. Now the width is 1/4. And then to figure out the height, I mean, here having the picture, you can kind of see what you're doing here. But the height, if I'm using right, would be approximately there, right? Now the other one we did was the parabola, like x squared. So we just did x squared everything for everything. But now my equation's all fancy. It's got like sine in it. Ooh. So to figure out the height, because I don't know if I know that right off the top of my head, you just plug it into the function. And I'm going to plug in 1/4 because that's like the x that I'm doing the height for, you know. So like I'm going to put the x in to get the y, you know, to get the height of it. So that'd be the first one. So this is like your height, right? This is your width. And there's one. So now you're going to do another one. So you got a quarter is the width because they're all a quarter. But now I'm going to use a half as my height, you know. So I'm going to get, I don't know what that is off the top of my head. I'm going to plug it into the function, you know. And I'm plugging a half in because that's what the x is. And I need the y, like up and down, you know. And then plus, I'll just put here 1/4. And then you do the next one. So sine pi, and then I gotta do 3/4. And then the last one, do you think I can fit it? Nope. Let's write it down here. 1/4. Oh, well this one's kind of lame. My right one on the end is like a ding, it's not like even a rectangle really. Anticlimactic, hey? Okay, so then for here, now you're just like doing math. You know, so you're doing 1/4 and then sine of pi over 4. You know, so sine of pi over 4. Where we got? Huh? Yeah. Good job. Be good at it. Gotta be fast. Fast. And then you got pi over 2. 1. And then 1/4. 3 pi over 4. And then zip. Okay. All right. So you do your trig business. And then you can, okay, what is this all over here? Okay, if I combine all these, how good are you guys at fractions? Good at these fractions, maybe? All over 8. Can we do this all at once? Maybe. We got 2 root 2's. See that? 2 root 2's over 8's. Are we good with that? And then 1/4 converts to 2 over 8. Correct. And then I can clean that up a little bit. Divide everything by 2. And there she is. That's the right Riemann sum. Much to my annoyance is they put this on no calculator frequently. So frustrating. So what I usually say is plug it in, skip it, come back until you have more time. Because like, you don't want to get points off because you're doing algebra wrong. So do the calculus part, skip it, come back if you have more time.
Why
Yeah.
Do we get a question if they ask about river underestimate? How do we usually do it that?
This one you can't, because this one for right, it's all about increase, decrease. That's more complicated. They'll say it's increasing the whole time, and then you can do it. Yeah.
Do you even need to make a drawing if you're like in a rush?
Nope.
Okay.
No. If you could do it in your head, that's the goal, like this one.
Okay.
The goal is to be if you can do a table. They're usually table people. They do the table and they say approximate the volume of the swimming pool, 14 minutes, using left endpoints for your approximation. So what I say is you can plot those quick to kind of get the vibe of what's going on with the rectangles. But here, what you're going to do is, well, wait, I have to read this question. So rate of water filled the pool at given time. So we have rate. There are 230 gallons at the pool at 1 minute. So we already got water in the sky. So this is like what's going on. You got a tank, and we already got water. Right? We already got 230 gallons. And as time goes on, we're adding, right? The rate is 35 gallons per minute. Then at 2, it's 40 gallons per minute. Someone's turning it up. And then they're turning it down, 22 gallons per minute, right? So all this stuff's going in. So what I'm going to do to find the volume, the way you do this is I'm going to take 230, because that's already what's in, and I'm going to add in, right? I want, what am I doing? Left endpoints. Left endpoints. I want to add in all these rectangles. And then you have to think, well, how many rectangles I got? Well, think about it. I'm going between 1 and 2. So here's one rectangle, right? 2 to 5. There's 2, 3, 4, 5, right? That would be widths. 5 rectangles with the data I have. Okay. If they don't approximate or tell you how many rectangles you're going to do, you just go with the data. Okay, left. Yep. So I have the 230 because that's already in there, and now I'm adding in water. Okay, so my width, okay, so for my first one, right, it would be like essentially this rectangle. Oops, I'm going to do colors. I'm going to do, this would be my first one, wouldn't it? This guy, between 1 and 2. The width of this guy is 1, right? Because I'm going between 1 and 2. So the width is 1. And the height, if I'm using left, would be 35. Okay. Hey. Yeah. 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 All right, and then the next one, okay, for our next rectangle, we're going between 2 and 5, right? So the width between 2 and 5 is 3. These widths are changing because they're only getting the, like they turned the spout down between this, between 2 and 5, right? So the width is 3. And I'm going to use the left endpoint, so I'm going to use 40. Okay. Then for the fifth one, I'm going 5 to 9, which is width of, what is that, 4? 5 to 9, 4. Left endpoint, 22. And then I go 9 to 10 with 9 to 10, 1. Left endpoint, 34. And then grand finale. What color do I want to use here? I guess this guy. 10 to 14 with a 4. Height 43. And believe me, they will make you do that without a calculator. It's really annoying. Yep, all of it. Figure it out. Okay, so just be aware that that's a thing. Do I agree with it? No, but they don't care what I think. Hey, now you might think like, well, what's the units? Well, 230, we already know what the unit is. But think about when you take minutes times gallons per minute. Think about what happens to the unit. Right? If I'm doing minutes times gallons per minute, I'm left with gallons. You can check everything in this class with unit. Okay? So this answer is in gallons. Okay? The 230 was already gallons. This thing, you're taking a rate times a time, rate times a time, rate times a time. So you're left with its correct thing.
Wasn't 230 gallons?
Mm-hmm.
How'd you
So-
get minute time? How'd you get that little thing you did down there?
Because from here. Because all these values are gallons per minute. Like the 35, the 40, the 22, the 34
I see.
are all rates. So you just multiply them and then you cross reduce. All right. Any questions? You guys are asking good questions. Okay, and then last one is midpoints. So we want 4 subintervals of equal length. Okay. What do we, 1 to 9? Oh, I guess it's not the worst thing. I usually do my widths first. So my change in x, aka my width, they're all the same, is going to be from 1 to 9. Can I do that in my head? Maybe, I don't know. 9 minus 1, hey, 8. And we want 4 rectangles. So that's 2. The width of all of these are 2, right? Okay. So then to find, again, they use m sub 4. It's a little outdated. They don't usually use that. Sometimes they do. But I'm going to find midpoint approximations. So my widths are 2. So that'll be easy. Whoops. All of them are 2, so that's nice. Didn't change like the other one. But then now I need to figure out what my height is. And I have to do middles. That's annoying. So to find middles, right, for the first middle guy, my height is determined when I plug a 2 into the equation. Right? If you look at the picture, because I have to do the middle one. So this is another way to write it, f of 2. This is your height of using your middle. Then you're going to do another middle. But you're going to use 4 to get your height. Right? You're going to use this guy. So you're going to go 2 times f of 4. Now these are easy numbers to get. Like you can look at the graph, get the values, but sometimes your equations are all psycho, you know? So it's really just paying attention like, okay, I'm doing the middle between 1 and 3. I'm going to plug 2 in because that's the middle one, right? And then now I'm going to do 2 with height, plug in 6, right? F of 6, oops. And then last but not least, 2 times f of 8. So you can plug in the values. 4 is 9. This you can cheat because the graph's already there, which is the best. Plus 2 times f of 5. And then math, 60.